to ask any questions along the way. So I think that Tim will take off with the presentation, and yeah, hope you'll enjoy this moment. We'll also be recording this, by the way, and that will hopefully get online afterwards, so we can share it with even more people. Just so you know.
If you could mute Ruben. Thank you for joining us. Ruben did a great introduction, so let me just kick it off with the presentation. Let's hope the technical things, the technical gods are in our favor. Let me see when the screen is there. Can you guys see it? It has a yellow thing for me.
Works for me.
Okay. Just let me know if something is off. Like I said, feel free to ask questions. You can also ask them in the chat if that's more convenient for you. Like some people are in a busy office, or just leave whatever, or leave them for the end. It should be as low effort as possible to ask questions. So feel free to do that in any manner you feel most comfortable with. So at Prefix, we've been working on a couple of projects like Pixie, which is the package manager you might know, I don't know, and rattler-build, which is something to build conda packages, which was kicked off by Wolf, who already created Mamba and also Boa, which was a previous package builder written in Python. Another one is big one is conda-build, and we'll get into this in this presentation because the work we've done was for conda-forge and getting a new recipe format and rattler-build on there. So that's what this presentation is about. So that's what we've been working on the last weeks. This week we've also been working on a bit more, and I want to quickly give a bit of an introduction, an overview, why this is important, what can people expect in the coming days or weeks. I know it kind of depends on how long it will take. What have been our experiences in doing so, and what still needs to happen. So just get briefly into the building of conda packages. So a conda package is something that contains files for installation in a certain directory prefix, and conda packages, unlike most package form, like 80% of the package formats are specific to the programming language or kind of specific, like wheels. But Ruby gems, for example, are quite specific, and everyone reinvents the wheel. But Conda is a bit different in that it's just like a more or less a collection of files without like a hierarchy like you would see in normal packages. And historically, a single recipe format was used to build all these packages, which was called meta.yaml, because I guess it's the meta thing that builds it. I'm never sure of the name. If anyone knows why it's called meta.yaml, please share in the chat. Conda packages are like that's the thing that you download, like the prefix of like Pixie downloads, and that you can that is hosted by Anaconda mostly. And we are introducing a new format, like a new recipe format, as opposed to meta.yaml, which is read by R2 rattler-build. So what does a conda package builder need to do? So it needs to read the recipe format in whatever format it is. It needs to render out maybe different versions of so it might contain might need to split it up in things like different outputs. What we call it needs to build a topological graph, which means it has to figure out what it has to build first. Like something in the package might depend on another package being built, and you want to pin that to a specific version. Then you need to build one or more variants, and how Conda does this is leave it up to the user, kind of how things are built. So you can use CMake, or you can use Rust, or you can use whatever, which outputs artifacts. Then it has some nice tooling in there to run different tests from recipes. Then it diffs the build prefixes and builds the diff into one or multiple Conda packages. Conda build only sort of does the topological graph. It just kind of builds the first thing, and then if it fails, it tries the next. And so it's like a really slow way. So there's also a lot of stuff in conda-forge to build such a graph, and part of that functionality is just available in rattler-build by default. So this is a method.yaml. So what you can see is like you see the package name, you see the version, you see a build number, and there's like this weird, like I don't know if you guys see the mouse by my mouse or not?
Yes.
Yeah, so you can see like the skip through, and then the comments imply that it's skipped for Windows, and these are like kind of like expressions, like simple Python expressions, more or less. Yeah, and it's kind of like, so that's part of it. So it's in common. So it's also like that makes it a bit hard to work with and to parse, but it works. And for example, the requirements you see, like if the build platform is not targeted for cross compilation things, then you want not like this requirement. So yeah, you can do different things in there. Then you also have like another example where you have what I was talking about before when I was saying render out different versions and build one or multiple variants. You can see like Python that is like conda, for example, conda-forge has the CI supports CDC files which specify different Python versions. So this script can be rendered out for different Python versions and be run multiple times in the CI. If I'm saying something incorrectly, then please correct me in the chat, maybe, Wolf. Yeah, and then there's like there's some Jinja things in there. So it's like this sdlibc is a function that gives you back the current C library for the specific rendered version of this recipe, and the compiler C6 is similar. So this is conda-build. So I'm just showing you the website. And what is conda-build? Conda-build is a Python program for building conda packages, and it's like been there since older, like people that really left conda-forge, like Mike Saharan and others, that they used to work on it a lot, and it's still being used. And it actually powers like whole of conda-forge infrastructure, so the building part at least. And conda-forge features are being rebuilt all the time with these recipes. So like when a new version comes out, you sometimes get like this automated thing where it upgrades it and then it rebuilds it using conda-build. Maybe there's some migration or like some pinning files that change, things have to be rebuilt, things like this. I see a chat ping. Someone just says hi. Hello. And just like a quick shout out to us, you can also view conda packages at this at prefix.dev. We have like this package index. If you haven't noticed, like kind of like similar to the Conda one, but a bit has some different features and is a bit faster. So sometimes can be nicer to work with. It doesn't index everything that Anaconda does, though. Then we have rattler-build. So we have conda-build. We have rattler-build. Rattler-build is the thing that was created by started by Wolf, and then I'm assuming that's what I said in the slides, includes the lessons learned by creating BOA. And it uses a new recipe format because Wolf was kind of fed up by method.yaml. And I'll get to that in a minute, why it's like significant that the new format had to be made, or like important, sorry, not significant. It can shave off a significant build time currently. It has some nice output and some nice errors, and the code base is simpler to work with. Like, in our opinion, sometimes Wolf shares like snippets that's been in conda-build for a long time. And that can be can be a bit, it's an older code base, and just like it has to be very stable because it's used a lot, of course. So we had a bit more leeway in the creation of rattler-build, and also could integrate some lessons learned that they were not able to do. So this is like NVIDIA that gave rattler-build a try, and then even like Mike Saharan, who was one of the original conda-build creators, said like, hey, it looks like a pretty good speed up here, maybe around 5 minutes out of a build of 8 to 10. So that's like 50% speed up or something of the sort. So imagine what that could like do for all of conda-forge. That's like kind of our big thinking here. That's rattler-build. Then the recipe format differences, like this is a bit like kind of like a little bit of a joke, but if you load the method.yaml into VS Code, by default it has like all these squiggly lines because it's not valid YAML, and the recipe YAML is. So on the left you see the meta YAML, on the right you see the recipe YAML. This is a different package though. We just chose one of these like Polarifies on the right, and which is they have Polarify. I think has a branch on conda-forge currently with the rattler-build recipe in there. If you want to check it out. But yeah, the similar functionality is there. So there's the build sections, there's requirements, there's sources, and some things have been renamed, and some things have stayed the same. Yeah, so and the big advantage is that it's valid YAML. That the schemas are available. Like we have this repo, if you want to check it out with recipe format. We've renamed things to make them more consistent and somewhat easier to parse. It's well documented regarding what does what. So not like maybe it could have a bit more better documentation, like what are these things conceptually, but yeah, all of it is at least documented on the rattler-build side. And we created, or by actually Wolf and I think Bas created two official SEP 13 and SEP 14, I guess, or SEP 13 part 1 and part 2, that introduced these recipe formats and advantages. So it's not like rattler-build is the only tool that can read it, but we should be aware that it's built like tool agnostic in the sense, so somebody else can make something even better in Common Lisp or whatever. So yeah, one of the advantages of the schema is that you have auto completion if the GIF is rendering out, which is kind of nice when you work with it, and it could be a lot better for sure, but it's a start. So this is how we maintain it. So there's a Pydantic schema, so you can view that on the GitHub, and you can render out like JSONs and other schema formats. Which is nice. It's kind of nice to work with it. That thing is a Pixie project, I think, and so you can just boot it up and edit it and make a pull request or whatever you feel like. Welcome. So we've talked about conda packages, right? We talked about different build systems, we talked about the different recipes, but you can use it locally and you can use it on your own GitHub actions, but it would be really, really great if we could use it on conda-forge. And actually Prefix started working on this a couple weeks ago. So just to get an overview of the conda-forge infrastructure again. So the feedstocks, which is not for like that, I recently learned that PyCon is feedstock has nothing to do with cows, but it's like kind of like the pellets, like the metal pellets that you load into the forge, the conda-forge, and they're like rendered out into metal or something. So that's an interesting side note. But those contain the recipes, and they the thing is, like, as opposed to like Rust crates or like Python packages or something, the thing is with feedstocks is that they're separate, because there might be a different feedstock maintainer as opposed to like the person actually maintaining that project. For example, CMake or something. Probably, I don't know, but I'm reckoning that assuming that the CMake creator does not maintain a feedstock. And then what the really cool thing is about conda-forge is there are loads of bots that take care of linting, updating the feedstocks, and doing other things, migrations and things like that. And because it's a kind of a centralized system, in a sense, you can do these large-scale migrations, like changing the pinnings of specific compiler versions or like libc versions, which you cannot do in PyPI. Like you have to depend on that person or crates for that matter. So that's kind of cool. And yeah, the conda-forge is pretty complex. Like this is the graph. So I'll get to that in a second, but we have like conda smithy, which renders the recipe formats. You have CF scripts and web services, and you have migrations. And the main part of the CF script is the autotick bot. You might have interacted with that updates your versions and other things, amongst other things. And conda and rattler-build build conda packages. So with the updated infrastructure, you see that conda and rattler-build have been rattler-build has been added, and we had to like change all of the intermediate blocks to be aware of the new recipe format. We could either do with very little code upgrade, or we had to make like some bigger changes, like CF scripts, which is the conda-forge tickbot and other things. And they create a similar topological graph. We introduced a little library, rattler-build conda-compat, which has an interesting story because we didn't make it Python 3.10 compatible at first, and then it was merged, and then it like kind of brought down conda-forge, crashed. It's like, and we had to like do a quick update to fix it, and we felt pretty bad about it. But then the whole crowd, Azure went down, and the CrowdStrike thing happened. So it was a minor outage in that sense, but it still taught us to be really careful. So we also added a lot of tests, and like tests for all Python versions up to 3.8, because app migrations, for example, is still using Python 3.8. Well, it could use a higher Python version, I think, but it uses that for now. So what have we done? Essentially, we've added rattler-build to conda-forge. Like it kind of works. It allows us to run the recipe. It allows us to build recipes. We've adapted the pots, and we've introduced that library I talked about. And what still needs to be done is parsing some recipe data from the feedstocks, and then essentially what's here. Like these small points, and we've been working on CF scripts a lot. There might be more stuff coming out of that, and we have to now, like, uploads are disabled for rattler-build uploads for now, and that has to be explicitly enabled again. So that's just like a minor thing once we go over it. So this is the demo, is kind of like just a recipe. So this is created by Bas, and was reviewed extensively by Jaime and others. And this creates the new, has the new recipe. So
Can you please inzoomen?
yeah, sure. So this has the new recipe in here. This is I think it's the same. And then the cool thing is that you can actually, it's already working. Like, we can look at the checks, and this is also always a bit annoying because you got Azure pipelines, and for example, take Linux 64, then you have to click again, and you're still seeing the screen. I have to zoom in again. Oh, zoom this screen in. The Docker build, but you do see the rattler-build output here. So it's working, and it's rendering the recipe, and it's building it. So that's pretty cool. And so that succeeded. So our conclusions for this is that recipe YAML will be easier to handle for both the users and machines. Hopefully, rattler-build wins in we think, we know it wins in speed, but we also think it wins in usability. And you will soon, quotation marks, be able to use it on conda-forge by replacing your meta YAML with a recipe YAML. And there will be support for both formats for a long while. So it will definitely not replace everything, but hopefully, we'll make it easier to make recipes, to run them locally, and also contribute, have people contribute to conda-forge and more easily. So we don't really have automated feedstock generation or something like that, or like there's some things that we could work on making the process of making a feedstock maybe a bit easier even still. But this is like the first steps that we have to take. So thank you. Julian also said, like, because we also upload the schema to so what is it, like the schema store? It works out of the box with VS Code and Z and other editors that support that. So you don't need to install like a specific rattler-build recipe extension or something, which is pretty cool. It does give you like then errors if you like try to work on a new feature for rattler-build and maybe change the recipe format. It only works with the publish format, like that recipe store, but it is super useful. So that's it. Thank you for your attention, and if there are any questions, and for any of us, feel free to feel free to ask, or if you have any notes, or if you want to blame us for the conda-forge outage, that's fine as well. So we'd like to hear what you think. Or in the chat, whatever is. And if there's any improvements if we could make to this whole show and tell format, this is the most people we've had ever joining, so that's good. It's getting better than that. Also, please let us know.
Thanks, Tim. I see there's some people typing in the chat, so let's see if there's some questions coming out of that. While those things are typing, while we're also working on the other conda-forge work, we've been also moving Rattler, so our backend library for all our conda work, to the conda incubator, just to get it more into the community and prepare for like sharing it with everyone, making sure that conda can integrate more with Rattler and sharing it as a piece of the community instead of a prefix owned package, to hopefully get more people on this same boat.
Is my microphone working? Yes.
A little bit.
One item to share for the whole rattler-build work is that we are very grateful to the Sovereign Tech Fund that has been funding the work to get rattler-build on conda-forge, and also many other items of things that we've been working on for the past year, essentially. No.
So I can maybe repeat that because he was pretty silent. We've been sponsored by Sovereign Tech Fund. We got a grant to work on all the rattler-build into conda-forge work. So thank you to them to help us get the requirements to do this kind of work. We're very grateful for such a big fund to help us with that. I was trying to find the link to the actual work that's specified by them. Maybe we can share that as well.
So MacPete was saying, are there any plans to integrate building conda package with Pixie, or how do you see it looking like? It does make sense to keep it separate. So we are actually working on trying to get the first prototype version of that will probably use rattler-build, but you would be able to do some build section in the Pixie file. So yeah, it's a very a thing we've actually been starting on this week. So you can see some PRs that move towards that, and we have some ideas for it. There's also an issue if you want to. I don't know if you could find a link, Ruben, that you could potentially give your feedback on. Yeah, there it is.
Just to share, we are working on this right now, so feel free to intervene, but this is definitely not finalized. We have really hard time to figure out what is gonna work. Tim, could you mute? This is not an easy thing to integrate, so we're still trying to figure out what is the best way to do this kind of stuff. Building a proper rattler build itself is very important, so the conda-forge migration is taking some time off of that part, but we think we have an idea to integrate it very well, and yeah, you will see more and more PRs about that these days. We are also splitting up Pixie, so Pixie was one package with all the files in separate modules, but not really separated into their own packages. So we're now moving a lot of the packages from Pixie into Pixie crates, which we can then share between tools. So for instance, we just pulled out all the manifest work into its own crate, and in theory it would now be easier to, for instance, have a Python bind to that crate, so you could interact with the manifest from either Python or Rust itself without having the whole Pixie crate as a necessary import.
Am I a bit more audible now? So there was a question about generating SEP13 recipes from PyPI sources from Bella. And we actually already have a rattler-build generate recipe PyPI and then foo, name of your package, a function in rattler-build itself. It works. It will definitely have some sharp edges, and it's like more or less alpha stadium. We have a similar function for cran, so for our recipes, but I'm not sure if we should keep it inside of rattler-build, which means it is written in Rust, which, I mean, it's nice because we would evolve it alongside of the schema and things like that, but it would also be cool if we would make it in Python or something like this so that other users could more easily contribute. And I also did play around a little bit with generating recipes for Rust, which is actually pretty easy since we have crates IO and they also have an API. And I also played with Ruby recipes for gems. That would also be doable. So I think that's definitely something that we're looking into to be able to build out entire ecosystems quite easily. And there's also ongoing work inside of Grayscale to use another tool that's called Conda Recipe Manager. And Conda Recipe Manager is basically able to take an existing meta YAML and convert it to a recipe.yaml. That is work that is being done by Skylar from Anaconda. And so the idea would be to kind of keep Grayscale as it is, generate the meta YAML, and then turn it into a recipe YAML using the Conda Recipe Manager. I'm not sure if the PRs, I think the PR was open at some point. Would have to look if it's done.
I think you're falling away, Wolf.
Oh no.
Would you
Did
repeat?
you hear my last sentences or not?
I heard them, yeah.
Maybe you're fading room.
Are there any more questions? Then still feel free to shoot them.
Someone's typing.
Also, we are working on Pixie as well during all of this work. So if there's questions on that, also ask them. Thanks, Woza. And if there's no more questions, then I would like to thank everybody for joining. This was a great experience for us, and nice to see there's interest in what we're doing. And hopefully we can do this soon again. And hopefully we see you there again.
Yeah,
Thanks for
maybe
joining.
one
have a
other
good day.
small thing is we actually recorded this meeting, so it's going to be on YouTube as well. If someone wants something blurred out, then let us know in the chat. But I think no one had their cameras on. And see you next time.
Thanks, guys.
See you next time.
Thank you. Bye-bye.